Hi, welcome back to the lab. So I have been away for a while. Last week on Sunday I did fail to upload a video simply because I didn't manage to finish the project I was talking about. I'm still working on it. This is a part of that project, but I have a very limited time, so I'll still finish it, and after that I'll come back with that video. So this is the subject of our discussion today. So this iron box. So sometime last week, as I was ironing my shirts, this thing overheated, and I burned one of my best shirts, and the reason was down to one failed component, and that failed component is this. So this is a thermostat. A thermostat is just a device that detects changes in temperature, then it switches on and off in order to maintain a constant temperature. So when this one failed, this ironing box overheated, and that's how I burned my best shirt. So today I'm going to explain a little bit on how this works, and let's see. So let's get inside. Now we are inside the ironing box, and nothing much is happening inside here, but there is a few components that you need to know how they work. And the main component of an ironing box will be actually we have two main components, that is your heating element and your thermostat. So but the most basic one will be the heating element. So there is this ridge here. So this ridge here is where we have the heating element enclosed, and also we have two attachment points. So this is the attachment points for our heating element. Now the heating element on this will be made from nichrome wire. So you have a piece of nichrome wire inside that heats up, and the choice of using a nichrome wire for any heating element is very simple. A nichrome wire has some very good characteristics, and if you're wondering what is a nichrome wire is an alloy of 80% nickel and 20% chromium. So the good thing about a nichrome wire is that one, a nichrome wire will have a very high melting point of around let's say 1400 degrees Celsius, and also nichrome has very high electrical resistance. So with that being said, that's why you see most of the heating elements are made from nichrome. Also nichrome is stable in air. When it is heated in air, nichrome will form a layer of chromium oxide that prevents the wire from breaking or burning out. That's why these things will live for ages without bad things happening, apart from my case here. So that's about this ridge here where we have the heating element. So after that heating element heating up, it will heat up the whole of this bottom plate here. Now we also need to control how we deliver power to our heating element. So we don't want the heating element to be always on, since it will heat up to very high temperatures, and sometimes this thing can heat up to red hot until it gets red hot. So we need to control the temperature, and that's the main work of this. So the whole of this assembly is what is known as a thermostat. As we are going to discuss about that in a little bit, and the way it works, it's like a switch. So you see these two contacts here. So we have this one here, yeah, this one and this one, and from this side I can see I have one wire here. So this wire goes all the way to the power source of all the way to the socket, and the other wire will be attached to our heating element. Also from the other side we have a wire. This will be your live from the wall socket, and also I'm seeing some indicating light. So this one will let's see how it's connected. So as you can tell, it's connected directly to the heating element, these two contacts here, and this one basically will tell you when the heating element is on and when it is off. So there is that, and this is where the magic happens. This thing, this assembly, this thermostat, and let's discuss this thermostat. So this is the new one. This is new. I don't know whether you can't really tell whether it's new or not, but this is the old one, the failed one. And the thing is, there is nothing much going on with it. It's just pieces of metals, and let's discuss how it works. In order for us to do that, I'll need to have a pen and a paper and draw something. So now the main part of a thermostat is a bimetallic strip. Bimetallic meaning it's made of two metals that are laminated together. These two metals need to have different expansion rates. So the metal that has the highest expansion rate will be on the outside. So this is the bimetallic strip. So you have a metal A and metal B. Let's assume metal A has the highest expansion rate in this strip. What that means is that this metal will, upon application of heat, this metal will expand more than metal B, and it will experience an increase in length, and after increasing in length, this strip will bend in this direction. So it will bend inward in this direction. Now we can take advantage of this and make some circuit, and a circuit that we can make from this will be like this. So we can have two contacts. We can have contact A, and we can have some contact here. So we can have, this is our contacts, and then we can attach our metal strip, and maybe we can attach some wires here. so like that. So still this is our metal A and this is our metal B. Now what will happen if we apply some heat onto this circuit or whatever device we have made here and make this stripe to bend like this? So we are going to have something that looks like this. Still we have our wires there. So we still have our metal A and metal B. Upon bending, you can now see that we have created a contact between A and B, and this one will allow the current to flow. So we have this section now is switched on. If we cool down this metal strip, it will go back in the state above this state, and we are going to lose this connection. That is the basic, the most simplest way of explaining this. So now this is what happens in this assembly. So you have your first contact here, this one and this one. So this is where you attach your two wires. So one wire will be from the power supply, and the other one will go to our heating element. So in between here we have the contacts. So this one, under some temperature ranges, this contact will be maintained. Now after heating up this metal here, this one expands and then it pushes this one like that, and then we lose that connection there, and that's when your ironing box turns off. And then after the temperature reduces, it gets back to the on position. Now what about controlling when your ironing box switches on or off? So we have this piece here, the one you use to rotate and set the temperature according to the clothes you are ironing. So this piece here, so this piece will attach to this thing here. The way this one works is that if you rotate, you will be applying some pressure down here, and depending on the amount of pressure that you apply, that one will determine the point or the temperature at which our bimetallic strip engages or bends. As you can tell, it is just that simple. Very easy thing to understand, and in most cases when you have your ironing box misbehaving, maybe you can't control the temperature. Of course, this is the main failure. So this assembly is what fails, and if you have such a case, this is what you need to be changed. So this one need to be changed. You just take your ironing box to a technician, and all will be well. So there is that. I think I have explained it in the best way I know how. So at this point I think I'm done. Remember to share, subscribe and do what, and stay tuned for the next video. So now I'm in macro, so let me switch on this ironing box and get closer to where the action is. So I'm getting very close. This one can be very dangerous. So you can see the light is on, and let's see, watch what happens. We give it some minutes. You can see the light is off. So I'm going to adjust the thermostat. You can hear the click. I have to be very careful here not to touch these naked wires. So if I adjust this thermostat, can see yeah, right. So, and the phone has started heating up because of the heat from this heating element. Well, I think I'm done. See you next week. So see you in the next video. This thing is very hot, can tell. Yeah, so see you next time.